also, speculations are useful to understand the idea of hypothesis and consequence. Because there is a theorem without graphs, that is important. For all hypotheses are the intersection of the abstract of information, that is the P infimum, with a speculation. And all consequences are the union of the abstract of information, the P infimum, with a speculation. Then this idea of selecting, when I am speculating, I am looking for speculations, and I am thinking on a problem of which I have information. Which is the best one of my speculations? We do that in the brain without numbers. Without numbers. But in a problem, for example, not of a passion, but a big problem of markets, in which the links of the graph are, for example, links of business. That would be a very technical, very big graph. How I know that the best speculation I can do in a concrete problem is that and not that? Why I can know that the best explanation I can say for this problem is that and not that? I think that this is a very important problem. And this cannot appear from looking at the figures. The figures can be useful to best understanding what she is doing. But the real problem is an abstract problem. It's not directly linked with graphs. Maybe.
Let me say two things. First, I think there is a graph theory that we can use before drawing the graphs. And this has theorems and has, you have mentioned the other day, Claudio has said me that very few that you can explore to find out the relation between that graph theory and the things that we are doing. So there is a theory of graphs. The second thing, it is very important. In the real world, you have no consequences. That is a strong affirmation. Why? Because when you try to draw a graph, in this theoretical one, you can say, okay, I have all the needed in my graph or in my model to ensure that this is a consequence. But in general, in the real world, that is a speculation. You only have a speculation because you cannot ensure, practically never, only in the mathematical world, that is our artificial one, that you have all the required information. So you are always speculating. Always speculating. That is very important in thinking in the practical.
I don't know what you but in the real world there are no speculations. In the real world there are facts. Speculations are in our brain.
When you try to,
in the real world,
when you try to work with conjectures in the real world, you have never the complete security that you have security. You are completely sure that you have all the required information.
Yeah, but look, Christian, imagine a problem in which the problem is related, for example, with linear programmation. And the events or the elements in this problem are linear multiplicities or linear subspaces of R at the power 45. Then you cannot draw this. There is no any graph that you can draw. It's impossible. You need to think on subsets of, for example, 23 dimensions. This could be a representation of a strict real problem of linear programmation. Then it's impossible to translate all the problems related with reasoning, that is with guessing or conjecturing, through graphs. There are a lot of cases in which that is impossible to make a graph. Of course, if you reduce the size of the problem, and you are talking only on 3, 4, 5, 20 subspaces, you can draw a graph. But there are cases in which it's impossible to reduce the problem to a graph. And let me insist, there are a lot of different problems coming from the real world, not in the real world, because the real world are just facts, but coming from the real world, in which you need to work with non-finite sets of elements. What will be possibly will be finite is the number of premises. It's almost sure, because we don't know how to work with an infinite number of premises. It seems that this is something that our brain cannot manage. I'm not sure, but it seems. But I think that the abstract approach to the problems is useful. And I agree with you that to explain to people, it is convenient to show very clearly the links. But the problem is an abstract problem that for me is very difficult. And there is again another problem that cannot be shown through diagrams. As for example, are the speculations computable? Are there algorithms, there are programs, computer science programs, computing all the speculations from a given set of premises? These kind of programs, they exist? Of course, in a non-exponential time, because if the time is exponential, okay, fine, there is a program, but it is almost for nothing. But I think that there are around all these that it's here to us, there are a lot of abstract and very, very important problems that are not completely related to the way of showing a lecture.
We completely with the graph is only a help and it's not a determinant for the solution of the problem. That is really completely. The other point is that probably when you try to reproduce a problem in the real world, you never are completely sure you have all the premises, because every time you listen to somebody study something, you must aggregate the arguments. In that case, it is because the definition